I put these two questions together because so we can have a comparison now on when I'm doing these solving for x, right? It looks that there's some similarities between them. So let me do the first one. This. Well, how do we start? Now, what is a negative I? Negative I, it is a complex number there, right? This is negative I. So the argument is pi. The modulus is 1. Therefore, this is e to the I pi, right? And x. Yeah, that is the left-hand side. The right-hand side, now, negative 1 and I, this is a complex number. So the modulus is square root 2, right? 1 plus 1 squared. Therefore, this is square root 2. This is square root 2. The argument is 3 pi over 4. So this number is square root 2 times e, the I, 3 pi over 4, right? Yeah. Since now we have a the angle could be plus 2 pi or minus 2 pi. You know, the period is 2 pi, therefore we can have plus 2 n pi. That will be the argument, right? N is an integer. Okay, so this side, left-hand side, is equal to, yeah, is e to the I pi x is equal to square root 2 e to the I 3 pi over 4 plus 2n pi. Okay, we are looking for x, right? So we take log of both sides. So I and x is equal to log square root 2. Take log, it means adding, right? Adding this log. This log is I 3 pi over 4 plus 2n pi. Okay, good. Then we divide it by I pi, you get x, right? Now, divide by pi. When you divide pi, it is actually multiplied by negative pi. So, negative pi, square root 2, right? This one divided by pi and I cancel out, right? 3 pi over 4 plus 2n pi. So we left over just simplify. We write the real part first. The pi cancel out. So this is 3 over 4 plus 2n, right? That is the real part. And minus pi I, right? Log square root 2 could be written as a 2, 1/2 log of 2, right? So 2 right here, because we don't like irrational numbers, you know. So that is our result for x. Okay. It's a nice question and it's a nice solution, a nice way of getting it. Okay, that is the first part. The second question, this one, Now that is a little difference, but there's some similarity, right? Because this one is as we did. This is equal to square root 2 times e I 3 pi over 4 plus 2n pi, right? Okay, good. Yeah. Then we take log of both sides, right? This is a negative I. Log x is equal to natural log square root 2 plus I 3 pi over 4 plus 2n pi. Yeah. So we divided by I, natural log x is equal to, when you divide it by a negative I, it's multiplied by a positive I. So it's I times natural log of 2. This I is cancelled. We have a negative left over, 3 pi over 4 plus 2n pi. Yeah. So then we get x, right? X equals to e to the I natural log square root 2 and times e to the negative, right? 3 pi over 4 plus 2n pi. Yeah. Okay, so that is almost done, right? This is, but this looks strange that we rather using Euler's formula. This one becomes e to the minus 3 pi over 4 plus 2n pi, and this is cosine log of 2, right? Cosine log square root 2 plus I sine natural log square root 2. Yeah, that is our the answer. So this x is a complex number, right? So the real part is this time this, and the imaginary part is this times sine natural log square root 2. Okay. So the n is an integer. The last question, no? The n is an integer. Forget that. Okay. Okay, that is the solution. I'm solving these two equations, which look similar. Thank you for your watching.